Welcome to Extembusu Career Guidance, Episode 2, AI Developer Career in the US, China, and Singapore. This series is about popular careers around the world, but with one difference. We use a holistic approach because careers are not just job descriptions, they're ecosystems. This episode is for AI developers working in the US, China, or Singapore, and people who are interested in pursuing this career. Here's the definition that matters. An AI developer is a software professional who builds AI capabilities, combining models, data, software engineering, and then maintaining that capability over time. The purpose of this guidance is simple: help you build a successful and fulfilled AI developer career in these countries. To do that, we'll use a 5-layer framework: career path, education and skills, people, direct context, and indirect context. Most people only focus on layer 1 and 2, but in real life, layers 3 to 5 quietly decide whether your career accelerates or stalls. Here's the typical AI developer career path: entry, mid, senior, lead, staff principal, then either management or deep specialist. And here's the key idea: your growth is judged by one repeating signal. You move from helping ship to owning systems, to setting standards, to scaling capability across teams. That's the pattern, everywhere. Entry level, 0 to 2 years. Your real mission is ship a working AI feature end-to-end with supervision. Typical work looks like simple ML features, classification, recommendation, basic chatbot functions, integrating APIs, LLMs into an app, cleaning data, basic feature engineering, running experiments, tracking metrics like accuracy, latency, and cost. Let me make this concrete. An entry-level AI dev might build a support bot that answers internal questions with RAG, or a recommender that ranks products using embeddings, or a moderation filter that flags unsafe content. Proof of growth: you can ship end-to-end with supervision. Mid-level, 2 to 5 years. Now you're owning real production components independently. This is where you start owning things like RAG pipelines, ranking models, personalization systems, moderation and safety layers, and your job becomes iterate quality using evaluation frameworks and error analysis while optimizing cost and reliability. A practical mental model here is a triangle: quality, latency, cost. You don't maximize everything. You trade off intelligently. Proof of growth: you can own and improve AI features over multiple iterations without someone holding your hand. Senior, 5 to 8 plus years. Now you lead architecture for AI systems, multi-model workflows, retrieval plus tool use, robust deployment patterns. You define standards like evaluation and dashboard safety checks, monitoring and alerting deployment playbooks, and incident response. And yes, you'll handle production incidents. This is a major difference between hobby AI and professional AI. Proof of growth: you can scale systems across teams and set best practices. Lead, staff, principal, 8 to 12 plus years. You're driving technical strategy, platform decisions, governance, long-term evolution, multi-team coordination. At 12 plus years, you typically choose one of 2 tracks: management track, build teams, own roadmaps, budgets, hiring, delivery outcomes. Specialist track, become the go-to expert, LLM architect, CV, NLP lead, responsible AI lead, research engineer. Important note: the best track depends on what energizes you. Do you want to multiply impact through people and systems, or go deep and become the domain authority? Here's the key: the latter is similar globally, but the winning conditions differ. US, specialization, plus product scale, more specialized roles, LLM engineer, search relevance, ML infra, safety. Fast growth if you deliver impact. Strong culture of measurable metrics: growth, engagement, revenue, retention. China, algorithm engineering plus performance optimization. Algorithm engineer is a common title. Strong focus on speed of iteration, efficiency, optimization, especially in consumer internet ecosystems like recommendation systems and ranking. Singapore, deployment, plus governance, heavily regulated industries. A lot of work happens in finance, government, healthcare, logistics. More emphasis on compliance, privacy, auditability, reliability, stakeholder alignment. Many roles become hybrid. AI engineer plus solutions architect plus stakeholder management. If you want a one-liner, US rewards impact, China rewards optimization speed, Singapore rewards trustworthy deployment. People usually ask, to become an AI developer, what are the required education level and skill sets? Here is the answer. Education, typically a bachelor's in CS, DS, math, stats, or EE. For advanced roles, master's is common, PhD mainly for research scientist roles, but in practice, strong projects and real experience can compensate for not having higher degrees, especially in product-focused work. For a tech audience, your portfolio is your proof. Required core technical skills. Programming, Python is essential, SQL almost always, plus Java, C++, Go in production. And please, data structures, debugging, clean code. That's the spine. ML fundamentals, supervised, unsupervised, evaluation metrics, cross-validation, bias, variance, deep learning frameworks. PyTorch is very common, transformers basics, training loops, optimizers, data skills, cleaning, feature engineering, dataset versioning, handling missing, noisy labels, structured data, text, and optionally CV video. A quick truth, many AI projects fail not because the model is weak, but because the data pipelines are unstable and nobody notices until production. Now other technical skills, Gen AI, prompt engineering, RAG embeddings, plus vector DB, tool, function calling. Evaluation, hallucination, grounding, safety guardrails, production engineering, APIs, REST gRPC, Docker, Kubernetes optional but useful monitoring, logging, optimized latency, throughput, cost reliability mindset, fallbacks, retries, timeouts, error handling, MLOps basics, model versioning, rollbacks, CI/CD for ML drift monitoring, experiment tracking, responsible AI, privacy, plus access control, bias, fairness awareness, safety policies, explainability basics when required. Extra note for real-world Gen AI, you're not building an LLM feature. You're building a system, retrieval, plus model, plus policy, plus UI, plus monitoring, plus feedback loop. Soft skills are not optional at senior levels. You need to explain trade-offs to non-technical stakeholders, collaborate across product, infra, QA, security frame business goals into ML LLM tasks, iterate based on metrics and feedback. Careers are social systems. Interacting with people, especially the internal and external stakeholders, happens every day. We will explain who are these stakeholders for an AI developer and what they care about. Basically, if you misunderstand stakeholders, you can be technically correct and still fail. When you work as an AI developer, a big part of your job isn't just writing models or code, it's working with people inside your company. These are your internal stakeholders, the teammates and leaders you interact with to actually ship AI features. Let me highlight a few of the most important ones. First, the product manager, or PM. Sometimes you'll also hear product owner. The PM is the person who turns messy, real-world needs into a clear plan. They define what the AI feature should do, what success looks like, and what should be built first. They care a lot about user needs, product goals, feature scope, timelines, and overall business value. If a feature doesn't move the needle, it's hard for them to justify. PMs tend to be outcome-driven and structured. They're usually very deadline-focused, and they're constantly balancing trade-offs, like speed versus quality, or ambition versus feasibility. So as an AI developer, one of the best things you can do is help them make good trade-offs by being clear about what's possible, what's risky, and what needs more time. Next, you have the engineering manager or tech lead. This person is more focused on the technical side of delivery. They review major design decisions, guide architecture, and help unblock risks that could slow the team down. They care about things like code quality, delivery speed, team productivity, technical direction, and risk management. Engineering managers and tech leads are usually practical and decisive. They think big picture, but they also care about process, because process is what keeps a team shipping consistently. If your AI solution is clever but hard to maintain, they'll push back. If it's scalable and reliable, they'll support it. And beyond these two, there are several other internal stakeholders you'll often work with. For example, MLOps or ML platform engineers who help you deploy and run models reliably in production. QA or test engineers who help make sure your AI features don't break the product and that edge cases are handled. And depending on your industry, you'll also interact with privacy, legal, and compliance, especially if your AI system touches sensitive user data or regulated decisions. So the key takeaway is this. As an AI developer, you're not working in isolation. Your success depends on how well you collaborate with these internal stakeholders, because that's what turns an AI idea into an AI feature that actually ships. External stakeholders are the people outside your organization, but don't underestimate them. Even though they're external, they're often crucial to whether your AI product succeeds. The most obvious example is customers. If they don't like it, nothing else matters. Let's go through a few of the most important external stakeholders you'll deal with as an AI developer. First, customers and end users. These can be everyday consumers, app users, enterprise users, or power users. Basically, anyone who touches the AI feature directly. And even when they don't give you formal feedback, they're still giving you feedback all the time through their behavior. What they click, what they stop using, what they complain about, and what they review. What do they care about? They usually care about accuracy, usefulness, and speed, but also trust, privacy, and how easy the feature is to use. Most users don't care that your model is state-of-the-art. They care that it works reliably and doesn't waste their time. Trait-wise, users tend to be outcome-focused and often impatient with errors. Their needs can be very diverse, and they usually value convenience. So as an AI developer, you have to design for real-world messiness, not perfect lab conditions. Next, cloud providers. These are companies like AWS, Google Cloud, and Azure, and you'll often interact with their solutions architects, account managers, and support engineers. They provide the infrastructure that makes AI possible in production: compute, GPUs, storage, deployment tools, and operational support. What do they care about? They care about usage growth, stable workloads, security best practices, and cost management, because AI systems can get expensive fast. Their traits are usually highly technical, with a scalable systems mindset. They're service-oriented, but also commercially aware, meaning cost and long-term usage matter. Then you have AI model and API providers. These are companies like OpenAI, Anthropic, Google, and Cohere, and you'll usually interact with partner engineers, API support teams, or platform reps. They provide the models and APIs you build on, plus updates, documentation, and troubleshooting help when things go wrong. They care a lot about safe usage, API reliability, rate limits, proper implementation, and of course billing. Their traits tend to be platform-focused, technical, policy-aware, and efficiency-driven, because they need their systems to stay stable at scale. And beyond these, there are other external stakeholders too, like data vendors who supply training or enrichment data, and regulators who shape what you can legally do with AI in different industries. So the takeaway here is, external stakeholders might not sit in your office, but they shape your work every day. Customers determine what good looks like. Cloud providers determine what's feasible at scale, and API providers determine what your AI can do and what it can't. People ignore context and focus on the job title. But context shapes pace, communication style, risk tolerance, governance, and what gets rewarded. We will talk about both direct context and indirect context. Direct context will focus on industry culture, ecosystems, competition, trends, and AI organization structure. Indirect context is about primary features of the economics, politics, and society in the respective country. Industry culture is the shared way of working in an industry, how teams operate, what's expected, and what behaviors get rewarded. In the US, the AI industry culture is innovation, ownership, and speed. People debate ideas directly, pivot quickly, and rely heavily on A/B testing. In China, the AI industry culture is execution speed, scale, and competitiveness. Its results first, with rapid release cycles, strong focus on optimization, and often a more top-down hierarchy. In Singapore, the AI industry culture is stability, trust, and enterprise professionalism. Work is compliance-driven, stakeholder-heavy, and the mindset is prove it works safely. Practical tip, don't fight the culture. Learn how to win within it. When people talk about the AI industry, it's not a single thing. It's an ecosystem. Different players depending on each other to move AI from research to products to real-world deployment. In the US, the AI ecosystem is led by three big forces: frontier model labs, cloud platforms, and startups. Frontier labs like OpenAI, Anthropic, DeepMind, and Meta build the core foundation models. Cloud platforms like AWS, Azure, and Google Cloud supply the GPUs, hosting, MLOps, and enterprise integration that make AI scalable. Startups then build fast on top: copilots, bots, and vertical AI products, while enterprise AI teams inside big companies deploy internal tools like automation and knowledge assistance. Behind all of that are the hardware layer: NVIDIA, AMD, Intel, plus data and MLOps vendors like Databricks and Snowflake, universities that feed research and talent, and regulators shaping privacy and safety rules. China's AI ecosystem is driven by tech giants and large-scale deployment. Companies like Baidu, Alibaba, Tencent, Huawei, and ByteDance often build models and roll them straight into massive consumer platforms. Domestic model providers supply local foundation models, while AI applications move quickly in e-commerce, social, content, and productivity. China also has strong industrial AI in manufacturing, logistics, robotics, and IoT, plus government-linked AI programs that accelerate adoption. A domestic-focused hardware and compute supply chain supports scale, and top universities and research labs feed talent and applied research into industry. Singapore's AI ecosystem is shaped by government leadership, enterprise adoption, and regulated industries. Agencies like GovTech and IMDA drive standards, funding, and responsible AI frameworks. Global tech firms run APAC hubs here for regional solutions and partnerships. Demand is strongest in finance and other regulated sectors: banks, insurers, healthcare, government, where AI is used for fraud, risk, compliance, and internal productivity. Consultancies and system integrators deliver many deployments, while B2B startups build practical enterprise tools. Research institutes and universities like A*STAR, NUS, and NTU support applied research and talent, and cloud providers supply the infrastructure for secure deployment. So, in one sentence, the US is led by frontier labs, cloud platforms, and startups. China is powered by tech giants and massive deployment speed, and Singapore is driven by government-led programs and enterprise AI in regulated sectors where trust and compliance matter most. Competition in the AI industry feels different depending on where you are. The players are different, the rules are different, and what counts as winning is different. Let's break it down by country: who's competing with who, what they compete on, and what it feels like for AI developers. US. In the US, competition is a multi-layer race between frontier model labs, cloud platforms, and a huge number of startups. First, frontier model labs compete with each other: OpenAI versus Anthropic versus Google DeepMind versus Meta. They're fighting on model capability, reasoning, coding, multimodality, plus release speed, safety and reliability, and compute efficiency. Second, cloud platforms compete with cloud platforms, AWS versus Azure versus Google Cloud. The battles here are GPU supply, enterprise adoption, managed AI services like training and inference, MLOps tooling, and bundling models with platforms. Third, the most intense layer, startups versus startups. Here are the AI industry development trends for the time being. US. The biggest trend in the US is the rapid move from chatbots to AI agents and co-pilots that can take actions, not just answer questions. US companies are racing to build AI into core consumer and enterprise products, productivity, coding, customer support, search, and compete on user adoption, distribution, and platform ecosystems. The focus is increasingly on making AI more reliable, multimodal, text plus image plus voice, and cost-efficient so it can scale to millions of users profitably. China. The biggest trend in China is the aggressive deployment of AI into large consumer ecosystems, content, e-commerce, social, payments, where AI directly drives engagement and monetization. Because platforms operate at huge scale, competition pushes strong emphasis on speed of iteration, optimization, and cost efficiency. China's AI trend is less about experimental prototypes and more about quickly turning AI into features that can be used by massive user bases, especially in recommendation, search, advertising, and automated content generation. Singapore. The biggest trend in Singapore is the rise of enterprise Gen AI, especially secure internal assistance and automation tools, often using RAG for banks, government agencies, and large companies. The key driver is productivity and service improvement. But Singapore's adoption is strongly shaped by the need for trust, privacy, auditability, and responsible AI. Instead of pushing the frontier model race, the market is focused on deploying AI safely in real business operations. You need to understand organizational structure, how roles and responsibilities are grouped, how decisions flow, and where resources sit. If you understand the structure, you can work with the system instead of fighting it. Now, here are typical AI organization structures in the US, China, and Singapore. US. In the US, AI orgs are often split into research, applied product AI, and platform teams with high specialization. Frontier model labs, like OpenAI, Anthropic, or DeepMind-style orgs, typically have separate teams for core model research and pre-training, post-training and alignment, data and evaluation, inference and systems for serving and efficiency, safety, responsible AI, and developer platforms for APIs, SDKs, and tooling. Inside big tech product AI orgs, like Google, Meta, or Microsoft, you'll often see applied AI product pods, search, ads, co-pilots, shared ML platform MLOps teams, AI-specific data engineering, model efficiency teams, and trust, safety teams. Indirect context has a broad and deep influence on everything, though it is only related to the AI developer career indirectly. It is always beneficial to understand and keep track of the development of economics, politics, and society in the country where you work as an AI developer. The following is just a high-level summary, but plenty of public information is available for you to have a much deeper understanding. The US has the world's largest economy, driven by innovation, consumer spending, and global leadership in technology, finance, and services. Politically, it is a federal democracy with strong institutions but increasing polarization between parties, which can lead to policy shifts depending on election outcomes. Socially, the US is highly diverse and individualistic, with strong emphasis on freedom of expression and entrepreneurship, but also visible inequality and ongoing debates around race, immigration, and social justice. China has the world's second-largest economy, powered by manufacturing strength, large domestic consumption, and rapid growth in technology and infrastructure, although it faces challenges such as slower growth and demographic pressure. Politically, it is governed by a centralized system that enables long-term planning and fast policy execution. Socially, China is shaped by strong collectivist values, intense education and work competition, and a society that is rapidly modernizing while balancing tradition, national identity, and government influence. Singapore has a small but highly advanced and globally connected economy, built on trade, finance, logistics, and being a regional hub for multinational companies. Politically, it is stable and highly effective, with strong state capacity and long-term planning, though political competition is more limited than in many Western democracies. Socially, Singapore is multicultural and pragmatic, with a strong emphasis on social order, education, meritocracy, and economic security, alongside ongoing discussions about cost of living, inequality, and national identity. Ever wonder how people actually break into an AI developer career in different countries? Here are 3 stories: the US pivot, the China veteran, and the Singapore career switch, and what each path teaches you. US, Mr. P, 28, California. He started as a software engineer at IBM in 2017. When ChatGPT launched in late 2022, he saw a platform shift and pivoted hard. A master's in computer software engineering, finished May 2024, plus constant learning, AI podcasts, Google Responsible AI Credential, AI PM Bootcamp. Most importantly, he built web apps using OpenAI and Gemini APIs to learn prompt engineering and LLM workflows hands-on. That mix, education plus portfolio plus community, helped him land a PM internship and then a full-time role. He even started a podcast to deepen his network. US formula, pivot fast, plus build proof, plus network hard. China, Mr. D, veteran path. He learned programming in the late 1990s, early 2000s when access was limited, copying C code from library books and testing on university computers. He studied physics, worked at a state-owned telecom maintaining mission-critical telephone switch systems, then wrote automation tools despite having no formal CS degree. After moving to a Beijing startup, he went deeper into open source, eventually joining the international AI community and becoming a respected contributor. China veteran formula, grit plus hands-on mastery plus systems thinking plus open source impact. Singapore, structured switch ecosystem. Mr. N studied materials engineering, got interested in AI through internships, stacked programming, data courses, entered a new grad pathway, and grew into AI work with strong team support and agile culture. Mr. B started in HR with a psychology degree, self-learned data science, applied it to HR tasks, then used Singapore's AI apprenticeship program to switch successfully, now an AI engineer at AI Singapore. Singapore Advantage, an ecosystem that makes switching realistic, training plus apprenticeships plus clear pathways. Ever wonder how people actually... Let's close with a practical summary. Don't think skills only. Think 5 layers. Level up by moving, ship, own, standardize, scale. Master stakeholders, technical work is only half the job. Match your approach to your country context. US, impact, plus metrics. China, optimization, plus speed. Singapore, trust, plus compliance, plus reliability.